Okay, so for this question, I've got the same ramp AB, yeah?
Yeah.
So this is important, it's point A. This is important, it's point C. This is important as well, it's point B. And this is important because it's the middle, right?
Yeah.
Okay. I have my reaction at A. I have my weight down the middle, which is mg. And the rest of it, I would have to read the text and just see what else there is. So I've included the mass. It says there's a particle of mass 2m. So I'm going to add 2mg. Okay?
Yeah.
I'll make this one smaller so it doesn't. And the rod rests on a rough ground, so this is going to be my friction. Yeah?
Yeah.
Okay. So I've included this now. It's held at equilibrium, so we can use our usual strategy. And it says explain why the friction is acting horizontally to the right. It's because it's opposing the motion. The particle, the ramp would slide to the left, right?
Yeah.
Okay, perfect. Part B mentions there's a tension in the string. So we just need to use that to add a tension over here. This is tension. Okay?
Yeah.
Okay, I'll make it a bit smaller. So before we carry on, we got treat it as a basically a 10-mark question all in one go. So let's just take our time. We're not going to rush it. We're just going to put all the angles in the right place. Okay.
Okay. I have a question. Why is the tension as big?
It says the tension is in the string.
But it doesn't say where. So why not somewhere else? Or it has.
In the diagram, where's the string? At B, right?
Okay, I understand. Okay.
But even if it didn't say that, you can see the string is pulling it at the top. Yeah?
Yeah. Okay.
So now we're focusing on the thetas. So if this is theta, isn't it? So I'm going to label this as theta. Theta, theta, theta. Any questions about that?
1 second. I think.
And I'm going to make them all right angle triangles. Okay.
1 second. Yeah, okay.
So in this is opposite.
Yes.
So that's sine. So this is 2mg cos theta.
And
this is 2mg sine theta.
And then 2mg, wait, just mg.
mg cos theta, mg sine theta. Yeah?
Yeah.
And this is opposite.
mg sine.
Yep. T sine.
And then t theta.
Mm-hmm.
T cos, yeah.
Okay. It's 3 marks. The question says, show that, basically it's saying work out the tension.
T is equal to 2mg cos theta.
So should we, what do you think you want to do? Do you want to do forces or moments? So let me show you how I would do it. If I was doing it, I would do it in my head and then decide. So in my head, I've got going right, I've got friction. And going left, I've got this. I've got too many unknowns. I've got mu, RA, T. I don't know. It's too many unknowns, right? And theta as well.
Perpendicular. Both are going perpendicular.
Sorry?
So is it moments?
Well, let's try one more thing and then we can decide, right? Force is up. I've got RA.
Yeah.
Down is mg, mg, and this stuff. So it's just too many unknowns again. So I think you're right. It is moments. Yeah,
I'm
I
saying
agree.
moments because horizontal, like it's not either horizontal or vertical. It's like going.
It doesn't matter about that. It matters how many unknowns we have.
Oh.
Yeah?
Yeah.
Like if you were to try to solve it, how many unknowns would you have? That's the issue. So you're right. We're going to do moments. So for part B, we're going to do moments around point A.
So we have.
So I need to first label the distances. So AC is 1.5A. And the whole thing is 2A. So this is 1A. And then this is 0.5A. Is that okay?
Yeah.
Fine. So my first moment is, I'm going to highlight them all in blue. 1, 2, and 3.
Yeah, okay.
Can you try to tell me the moments for all of them?
Yes.
Okay. What's the first one?
But for example, 2mg sine theta, what is this?
What do you mean?
Like, is it like horizontal, vertical? Like, would we use it in finding something?
We don't need anything. We've worked all the components out.
No. I'm just like asking if we would use 2mg sine theta in something.
Not right now.
But in general.
What do you mean? No, we won't use it in anything. No, you're right.
Okay.
Probably not. Like, we don't know if they make a hard question next year, but we've not needed to use it in any questions so far. Cool.
Okay.
So what's the first moment?
T.
So force times distance. So mg cos theta times 1a, right?
Yeah.
And the next one?
2mg cos theta times 1.5a.
Good. Equals, and the other one?
2a times t.
Good, well done. I'm just going to tidy the equation up. So when I tidy up, I get amg cos theta plus 3mg cos theta, 3amg cos theta, so that's 4amg cos theta in total is equal to 2at. Divide both sides by 2a, so I get 2mg cos theta equals t. So we got it correct. Yeah?
Yeah.
Okay. Moving on to part C. Now we can just use forces left and right, the vertical force. So the vertical force is RA plus Whoops.
Okay.
Hold on. I made a mistake. This is not.
Yeah, the other one is.
Yep. It's not rubbing out. 1 second.
Mhm.
Okay. Going up is t cos theta.
Yeah.
And also r directly up. Does that make sense?
RA and T cos theta. Yeah.
Yep. And what about going down?
MG,
Yep.
2mg.
Good. We can solve it. So now we've got RA equals 3mg minus t, which is, we know from the previous question, t is 2mg cos theta.
Times cos theta.
Yes. And we also know cos theta is 3 over 5. So RA equals 3mg minus 2mg 6 over 25. Because I squared the 3 over 5.
Yeah.
Which means RA equals
3mg minus 2mg is 1mg.
Yeah, I get 63 over 25 mg. No, I also had to times it by the 6 over 25, remember? So
Oh, yeah,
2.52 mg.
Okay.
So we got something wrong because the correct answer is 57 over 25.
Okay,
I'm just going to check what I did wrong. Up is RA plus t cos theta. Down is 3mg. I'm just going to go slowly on this in case I made a silly mistake. So I get 3mg minus t times 3 over 5. So I get 2mg. Okay, I think I know what I did wrong. So 2mg times 3 over 5 times 3 over 5. Well, let's just quickly check. So that's yeah, I got it. I got 57 over 25. It was just a silly mistake.
Oh, okay.
Okay. So that's 7 marks for that, 8 marks for that. Okay.
Okay.
And then the final one is 4 marks. It says something about the friction and it says work out mu. So part D is just going to be resolving forces left and right. So do you want to try this one yourself? What are the forces left and the forces right?
Left is T sine. No.
Yeah.
Right is.
You're right. You were correct.
Okay. Left is T sine. I forgot what's this called.
T sine theta.
T sine theta, yeah. Wait, but how do I know that it's left? That's going left and not right.
Because you can see that if I was to join it up, I have to go up and left. It can't go right. Otherwise, I would do a triangle this way.
Okay. So T sine theta, and that's it. And then right is mu RA.
Good.
So it's equal to mu RA.
And we know RA is 57 over 25 mg.
And we know sine.
Yeah, we can work out sine theta really quickly.
4 over 3? I don't know.
Can't be more than... It may be 3 over 4. It can't be more than 1.
Ah, okay. 3 over...
Yeah, 3 over 5. Wait, hold on 1 second. 4/5. So 0.8t equals 57/25 mu mg. Mu is equal to 0.8 times 25 divided by 57. 20/57 t. There's something missing. Do we have t? Oh yeah, we have t, right?
Yeah.
So t was 2 mg cos theta. Oh wait, I'm gonna just redo this part then. It'll be easier.
Okay.
So t is
2 mg cos theta times sin theta. 4/5.
I'm gonna make a mistake. Let me go slow. 2 mg cos theta sine theta equals mu 57/25 mg.
Okay.
I'm gonna first cancel the m and the g. So I get 2 times 0.6 times 0.8 equals mu times 57/25. Yeah?
Yeah.
So mu is equal to 2 times 0.6 times 0.8 divided by 57/25. And let's just hope that's the correct answer. 8/19. I'll check it in my calculator.
The shared.
So
Don't
yeah,
forget.
the answer was correct.
Okay.
So I recorded both of them, so I'll try to share you the video as well if you need to go over it. But as I said, there's like 10 marks every paper, so if I was to show you really quickly, just if I zoom out, you've got this one here.
Can you
This one here.
like highlight them and then I'll try and do them alone.
Yeah. Look out for them yourself as well. You can see it every time there's a ramp. Yeah.
Oh, yeah.
So it will be a similar style every time. But yeah, I'll send you this and just try to practice as much as you can, as soon as you can as well, so whilst the memory is fresh.
Okay.
There's also good questions in the textbook in the exercise for static rigid bodies. It's called static rigid bodies, okay?
Okay.
Okay, perfect.